Good. I'm Jack Rocker. Joining me this week is Brian Cheshire. He is I like to call him the mouth of the South, but he is our director of water wastewater. Hey, Brian, how's it going?
How's it going, Jack? Doing well.
Also joining us this week is Jennifer Gleesberg. She is our director of performance products. How's it going, Jennifer?
I'm good. Thanks for having me.
Well, I wanted to have these two in because they've been making waves in the industry, giving presentations on some new technology that Tnemec is offering, and it's kind of changing mindsets about the way we think about this technologies. Why don't you start with, water-based coatings? They've really taken the center stage recently.
Jack, I think for many years, they've intrigued a lot of people. They've been appealing just for some of the inherent, composition of it and some of the sustainability goals, the safety of it. I would say application. I mean, there's really a whole gamut of things. But the problem has been through the years, and I don't know how it's been for you, Jack, in your career. I've been in the industry for over 22 years now. And when I started, utilizing a water-based coating in any kind of high-performance situation was almost taboo. People were very scared of them just because water-based seemed to be synonymous with lower performance.
Right.
But that has been changing recently, and I know we'll get into that more today.
Yeah, I think that's the industry mindset that we're trying to change, and that what we're really here to talk about is over the years, first, I guess water-based coatings really aren't that old of a technology compared to our older solvent-based brother.
That's correct, Jack. We've had quite a bit of water-based coatings that have been around for a long period of time. They just might not, because of VOC regulations and legislation and things of that nature, might not have always had to have been used. And the solvent-borne have been more pertinent and easier application, those types of things with regards to corrosion protection and whatnot. But advances have now brought on newer water-based coating technology that we're going to kind of discuss throughout this podcast.
Right. And I think the water-based gets a bad rap based on some of that earlier technology, right? So you think it's not as durable, you think it's not as hard, it brings in some good flexibility and things like that, those earlier water-based coatings. But realistically, we know that solvent-based coatings have been the industry standard for years. So how have the water-based alternatives caught up with the performance and durability and overall asset protection?
Well, I'll kind of begin speaking from the water industry side. In 2020, which I feel like, when 2020 hit, everybody was trying to figure out, how to make it to the next day, really. And so there was a lot of things that happened in industry that really kind of fell under the radar. One of those things that happened in 2020 was two Tnemec products, Series 98 and Series 1220, both received NSF approval, NSF 61-600 approval. The reason that's significant is that Series 98 is a water-based sink ridge primer. Series 1220, water-based epoxy. And I didn't stutter. You heard me right when I said these got NSF approval, which honestly turned the industry on its head. I mean, just saying it out loud sounds borderline insane, but saying that you're putting a water-based coating in water immersion.
Right, and that's the dot I was going to connect there, is that for those of you not in the water industry, NSF service is a lining service. So putting a water-based coating in a lining service, especially water, really kind of defies everything that you think about water-based coating. Where have you seen the improvements and changes in the architectural market?
As I mentioned, sustainability and regulations that are out there. You're looking for compliance with LEED and other sustainable standards that are out there. And just in general with application, with being able to have improved worker safety and environmental concerns, not just in the shop, but also in the field.
So we're seeing this, and we're seeing the technological advancements. It's obviously more sustainability. We know those are all general good things to focus on. Where are the asset owners and specifiers? Why do they care about sustainability?
Well, I would look at it from a few different standpoints, and I know Jennifer can probably talk more to the pure environmental piece, but by definition, if you think about sustainability in terms of life cycle, if you think of it in terms of service life, being able to offer a system that not only, number one, is more VOC compliant, zero HAPs in the case of these products, but think of it in terms of long-term performance. We'll get into some performance specifics here in a moment, but when you benchmark these new water-based technologies against traditional solvent-based technologies, for instance, we'll talk a little bit about ISO 12944. We'll talk about salt fog. We've been honestly surprised when you benchmark these water-based systems, these water-based technologies against traditional systems, you're not compromising performance. That wasn't always the case, as I mentioned.
Right.
And so if I'm an asset owner and if I can basically kick the can down the road between repaints a little more. If I can extend that repaint cycle or extend that time before I've got to come in and basically come to an end of life scenario on the inside of my water tank, blast it out and start over. You got to think every time a contractor mobilizes and does that work, it's a disruption to the community. It may be the case where this tank may be in the middle of a neighborhood. So now you've got the nuisance of having to shroud this tank and having the noise and, possibly any other light environmental impact. And me as an asset owner, if I can now push that out to say 20 years versus 12 to 15 over time, that really makes a pretty big impact on the overall sustainability as it relates to asset management of that tank.
Yeah, there's a whole lot that you can get into with asset management. And obviously, the construction of steel can be rough itself and usually more aggressive than an application of a coating system. So if we can keep that coating system in place and keep that asset protected, the longer that even the asset lasts, the better it is for the environment in the long run as well. You've hinted at some of these performance tests. Let's get into that. ISO 12944, that is ISO's great exterior weathering classification. That breaks it down, everything from rural environments to offshore environments, chemical environments. How are we doing with our water-based coatings in the ISO 12944?
We basically took a full water-based system and then a full solvent-borne system and took those and compared them to each other. And both systems, the water-based and the solvent-based, both conform to ISO C5 high, which is the higher level of performance within the ISO standard. That misconception per se that water-based doesn't perform as well as solvent-based in that type of scenario isn't necessarily true. You're seeing the same type of performance, if not better in some cases, with the waterborne technology. And
I'd like to add there, Jack, I would say in the start of my career, you were fortunate, I think, if you got decent performance out of a water-based system in say, an ISO rural system, which now all the audience knows that I have a hard time saying the word rural. So,
I as well.
Okay.
Break in the mouth of the South.
That's right.
Yeah.
It make me say that enough times in a row and you'll break me down.
So the area that's not urban, what would you call that?
Rural.
Okay.
But basically, to Jennifer's point, there's different corrosivity categories within ISO 12944. And like I said, even just a decade ago, you could not even imagine of getting a water-based system to perform at the levels of C4, C5.
Right.
And now we have that with these new technologies, with these new resin systems.
I really think a lot of that could be attributed to being able to come up with a water-based zinc-rich coating. We haven't really talked about that, but I'm not aware of really any other ones out on the market that perform.
You're correct in saying that. And I would say, looking at the zinc-rich technology, it's a really unique curing mechanism that happens within this film. Ultimately, what you end up with this Series 98 is you have a very dense particle-to-particle contact within that coating film. And if you follow zinc-rich coatings, if you know much about them, when you start getting into that sacrificial performance, that galvanic protection, ultimately it really comes down to that particle-to-particle contact. And so even at a lower percentage of zinc dust in the dried film, with this new technology, we can give you, I would almost venture to say, performance more comparable to an IOZ than, say, a traditional organic zinc.
Wow, that's impressive. For those of you who don't know, traditionally, if you look, the IOZs do perform a little bit better than organic, but once you put them in a system, that usually is kind of equaled out. But one of the things that I think is cool about zinc and water-based is, I know a lot of people have tried to come up with that technology for a long time, and when you look into that high levels of performance, we all know in this industry, in industrial coating, zinc is where you get your high levels of performance. And so the ability to be able to offer that in a water-based vehicle really is a way to drive performance through water-based technology.
And I'd like to add too, Jack, when it comes to this particular zinc-rich coating, when you look at, just speaking of the water market again, looking at it through the lens of that, all the zinc-rich coatings that are really used in the water market are all moisture-cure urethane technology.
Right.
Which contain an isocyanate.
Right.
There are parts of the world, there's even pockets of Canada that we're seeing that are starting to restrict the use of isocyanates.
Sure.
If you look at this Series 98, not only do you have the low VOC, the zero HAPs, the high performance, but it's also isocyanate free.
Agreed. And then you combine that with this great dense cross-linking water-based epoxy that is good for immersion. So like we've said before, water-based technology is relatively new, and water-based zincs are even newer than single-component water-based coatings. And in the first generation, they were harder to apply than their solvented counterparts. Is the Series 98, how does its applications qualities?
So, Jack, for first generation zinc-rich, water-based zinc-rich coatings, I've over the years, been able to play with some of those, and traditionally, it really required dedicated equipment. You needed either a pressure pot or a pump that may contain certain components to where, you wouldn't have the rusting and you wouldn't have other challenges there. But when you look at this particular binder or this particular resin system, the beauty is it basically takes the same equipment as the solvent-based counterparts. And so it does not require necessarily a dedicated setup or, an additional purchase from a contractor or from a shop.
Yeah, with regards to like the recommended DFT, the application between a water-based zinc, an aromatic urethane zinc, and then an aromatic urethane zinc rich that's NSF and versus non-NSF. They all can brush, roll, and spray. Their atomizing pressures are all very similar with regards to PSI, and their volume solids are somewhat close to each other in terms of that. And we're seeing that not just on the zinc side, we're seeing that on the epoxy and the top coat side as well. So very similar in application characteristics throughout the whole water-based system.
So I think, that's one of the misconceptions. Are there any other misconceptions about water-based coatings that you've run into in the field? And how do you address those to build trust into the new technology?
It really comes down to seeing how the water-based performs in comparison to the solvent-based. And based on application characteristics, salt fog, cure times, all of those situations, humidity, we're seeing, like I said, if not similar, very similar in testing performance to the solvent-borne counterparts or better performance.
Jack, another one that I hear a lot, and I would say about every time I give this presentation, this is question 1 and 1A, I would say, but the concern about flash rusting. And if you look at Charles Munger, that's a name I would say he's probably the Yoda of the corrosion industry. I mean, he is
for sure
one we all study. There's a quote by him, actually in the world famous Munger book, which I believe you've read cover to cover 8 times now.
Yeah, totally. I have it memorized. Well, ChatGPT does.
So you probably already have this quote memorized. So I'm just going to indulge you anyway. But Mr. Munger says in his famous book that basically much of the early sales of waterborne epoxies were really delegated just for commercial structures. And he says the reason for that is due to flash rusting and deficient performance on steel versus solvent-borne epoxies. So this is Mr. Munger just a few years ago, echoing a lot of these concerns that we've already talked about. But look at flash rusting. I'll just throw this out. There's parts of the world where VOCs have really been a greater concern than maybe some parts of the States. And so in the marine market, for instance, in ballast tanks, there's a case history that Tanemic was involved with. And it was a situation where we came into a ballast tank and a first generation water-based epoxy had been utilized in that. And looking at pictures of it, of the state of that tank, shortly after application, you had flash rusting at basically all the angles, corners, welds, all of those types of areas where maybe the film build was a little less. And when we came back and redid that, because of some of these next generation resin technologies, and on top of that, some of these next generation additives.
Yeah.
Additives have come a long way. And these next generation additives have really helped to mitigate some of those concerns, which I do want to throw out. It's one of those things, kind of like with environmentals. I mean, you always want to have best painting practices, but I will say that with these next generation materials and additives, it's a little less of a concern than what it used to be. Whereas it used to be almost a known entity, a 100% certainty that was going to flash rust. And with these, we're just not seeing it near as much as with those first generation technologies.
Well, to be fair to Munger, I do believe that book was written a lot. You pulled the Gen X Zennial just a few years ago. I think that book was written in the 80s.
Back when we were in diapers, I guess.
Yeah. So to be fair to Mr. Munger, I don't think he was wrong at the time.
No.
But if we lock into mindsets where we don't grow and learn and develop and innovate and just hold what was true back in the 80s for coatings, well, I think coal tar epoxy would still be one of the top selling coatings in the entire face of the planet and things like that. So
and vinyls too.
And vinyls. And if anybody's ever had to do an overcoat of a vinyl, they realize the biggest drawback of that material. You know, vinyls, if you put the wrong thing on top of them, they just start coming off. Technology needs to evolve. We need to accept it, and we need to take a look at older mindsets and try to be accepting of the data that's being presented to us. I would say, you know, from your guys' perspective, how can, you know, we've talked about a lot of this stuff. We've talked about how water-based coatings are meeting the performance of solvent-based coatings. We've talked about how they're sustainable. How do you feel that specifiers and asset managers can make smarter choices when it comes to balancing performance, sustainability, and cost in coating selection?
You know, Jack, it really is a holistic approach when you look at this. And as specifiers, some of the pitfalls you can fall into, you know, just looking at just cost or looking at just initial CapEx can be a shortfall sometimes, you know, and granted, there's times that may be appropriate, but I would say if you truly are looking at it through the lens of asset management, and I touched on this earlier in the podcast, but when you really weigh out that initial cost, but then you factor in the service life, factor that out over a period of time, and you look even at things like the time value of money and assess that in, you really come out way better on the front end specifying that higher performing system. And I want to state too, I mean, we have numerous high performing solvent based systems.
Right.
So I always give this caveat when I give this presentation that solvent based systems are not going away.
Right.
They have a great place in them, or a great spot in the marketplace. They're going to continue on. But when you talk about some of the drivers for change, when you start looking at, you know, some of the VOC laws, you start looking at, I touched on isocyanates. You start looking at things like Oxol 100.
Sure.
We didn't really touch on that a ton, but when you look at some of your epoxies that go into potable water immersion, you really have a few strategies you can look at. You can either do 100% solids. You can go with a solvent-based technology. But to pass NSF 600, you have to look at one of these exempt solvents.
Sure.
And unfortunately, those are some of those substances that are starting to be looked at. And we're worried in the industry that possibly in the next decade, we may not be able to formulate with those anymore. So now you look at that third option. You look at water-based coatings. So there's 3 strategies you can use as a formulator. And like I said, the water-based portion of that was not really on the table up until recently.
Right. Not only have we made great advancements in the primer that gives you great corrosion protection for a very long time, but Tnemec has also made some really cool advancements in weathering resistance out of the water-based technology. Would you guys like to talk about the new technology and how it's improved on weather, color, and gloss retention?
Yeah. So as Jack mentioned, there are some very high performance water-based top coat options for exterior applications out there. These materials are really low in VOC, and Brian mentioned on the zinc side with free of isocyanates, and the same rings true for the exterior top coat, which helps differentiate them, with regards to the solvent-based polyurethanes that are currently on the market. So there are more traditional coatings with the traditional coating film, the particles, this is a silicon grafted composite, and typically the silicon particles are spaced out with an unevenly dispersed, whereas our Series 1061, which is the next generation water-based coating, has the evenly dispersed particles. So it helps maintain the coating film, and it helps with UV degradation and protection with regards to that. In addition to the exceptional color and gloss retention that it offers, these materials are great with physical attributes as well. And some of those, the curing, the salt fog, and things of that nature that I mentioned earlier, those are all big pieces that this type of product is performing to really well against the polyurethane technology.
Yeah, I mean, I think, would it be fair to say we've even been surprised with how well it has performed?
Absolutely. In terms of color and gloss protection, we are seeing really good numbers with regards to EMAQA testing, which is, it closely correlates with South Florida weathering exposure. measure. So 4,500 hours of Aqua, and we're seeing really good results with regards to color and gloss.
That's arguably, we're seeing performance better than a polyurethane. Would that be fair?
Absolutely, yep.
Yeah. And a polyurethane is kind of the standard top coat in the industry across the, it's pretty robust. It's kind of a jack of all trades. It has good performance, but not necessarily great performance. But the old traditional polyurethanes outperformed old traditional water-based technology. So it's really cool to see the water-based technology overtake some of the standard solvented technologies.
Jack, I'd like to add, looking at it, once again through the water industry. So most of the listeners are going to be familiar with a D102,
right?
Industry consensus standard. Basically, the scope of that standard is it lays out minimum requirements for coating still water storage tanks. And within that standard, they have different inside coating systems, ICSs as they're referred to, and they have OCSs, outside coating systems. And one of the systems in D102 for many years has been OCS-7. And what that consists of, it's a epoxy waterborne primer, and then an epoxy waterborne, in some cases, epoxy waterborne intermediate, but then it utilizes a water-based polyurethane. And if you look at some of the resources out in the industry to evaluate different systems, one of the probably the more famous ones is the AMP paper that gets redone, I guess, every year.
Sure.
Penned by KTA Tater and then some other people in the industry. But it's the expected service life and cost considerations of coatings. And one of the systems that they lay out in that is that OCS-7. And if you kind of look at the performance of that across different corrosivity categories, you can almost look at the average as a whole of say, 10 years.
Okay.
And so here we are. I mean, we're really evaluating those first generation water-based materials. And what industry is telling us is that system should only last 10 years.
Right, yeah.
But what we're seeing, as Jennifer mentioned, when you're looking at these ISO 12944 tests, these Aqua tests, we're seeing not quite the level of, say, a fluoropolymer, but we're seeing, performance, as you mentioned, Jack, that are kind of hitting in that midpoint between, say, a polyurethane and a fluoropolymer. And I would like to add on top of that another great advantage of this new Series 1061 Oculox, which by the way, I'm having a hard time kind of getting used to that name. It sounds like something that my doctor would discuss with me, at my annual checkup. But Series 1061 Oculox also dry falls.
Yes.
So think about this. If you're a tank maintenance painter, you're an asset owner, and let's say you've got a tank that may be in a very hard to get to area, or maybe a congested area, and you may not have the money. Say you're a smaller utility, or say maybe you're a bigger utility. You just don't have the money allocated for this tank. You now have the ability to put a high performing top coat on this tank that gives you dry fall capabilities.
Yeah, and that's huge. We just recently did a tank of it, and it was one of the most beautiful pictures I've ever seen of a tank, because it was out in the mountains, but like right underneath the tank was this whole subdivision. And it's like, you know that they had extreme confidence to use it with those dry fall capabilities.
Yeah, and that was a complete system of water-based. So you're looking at a water-based primer with regards to that, and the water-based Series 1061 Oculox as the top coat.
And, I kind of say, if I was a specifier and I could stress one thing, you really want to take the time to sit down and evaluate the true cost of something. It's really easy to look at a per gallon price and try and make a decision that way. But that per gallon price doesn't tell you anything about applied thickness, longevity, system design. There are a lot of ways to provide a really good, high-performing system that is sustainable, that will give you lower costs in the long run, in the life cycle of that asset. And it's really important to factor in asset life cycle costs, I think, more than just that price per gallon.
Absolutely. Tanemic has seen it before, and we then worked on a paper and a life cycle tool that you can do on the water tank side to measure different systems and see over the value of that, life cycle, what is the best option as far as cost goes. So seeing it laid out, as Jack and Brian mentioned, really does show you and take all the thought process out of it, looking at, a 5-year system versus a 15 to 20-year system and what you want with regards to performance and the coating system that you're choosing.
And don't just assume that the coating manufacturer telling you that something is a 15, 20-year system. Have them show it to you.
Absolutely.
There's a nice balance of performance testing that we can use to predict the longevity of a coating system. It's important to remember as you're evaluating these technologies that the water technologies are evolving. They are growing. They are getting better as the world moves towards more sustainable goals even within formulas and VOCs and LEED and those kind of things. You will see more of an impact on water-based technology. It's important to know the difference, though, between some of those first generations and the truly new and innovative. So I'd like to thank you guys both for coming on to talk about these products. If you guys have any more questions, you can find stuff at Tnemic.com. If you want to learn more about the water-based products that Tnemic has to offer specifically, go to Tnemic.com/H2O. Again, you'll find a lot of information about this exciting and emerging technology. Jennifer, Brian, thanks for coming.
Thanks.
Thank you for having us.
And everybody else, we'll see you next week.